All right, so now that we've covered 4 of our major reactions, we want to ask ourselves, when we have a certain set of conditions, what kind of reaction is going to occur and what kind of product will that give us? And so there's 2 main things that we want to look at. The first is the substrate. The second is what reagent you have. And then we can also look at some other things, as we'll see shortly. So a lot of these problems, right, you're going to have some kind of substrate. In this case, it's probably going to be some kind of alkyl halide. We're going to add some kind of reagent to it under some set of conditions or solvents. And that will result in some type of product. And so when we do these problems, it's important to remember that oftentimes we're just predicting the major product, not necessarily all of the products. And so again, our options are SN1, E1, SN2, or E2. And so we can have different substrates. We can think about like a methyl substrate. We can think about maybe like a primary substrate. A secondary substrate. In this case, secondary and then allylic and benzylic will be very similar. Right, so even though this right here is technically a primary alkyl halide, it's allylic, and so it behaves more like a secondary alkyl halide. And same thing for the benzylic position. And then finally, we have tertiary substrates. And so that's our options for substrates. Let's see what reactions are going to occur. And so if we think about SN1 and E1, they require a carbocation. These things are not going to be stable under methyl conditions, and so you can't have SN1 and E1 with methyl alkyl halides. And then E2, we need a beta carbon. If you have a methyl, you don't have a beta carbon, so you can't have E2. And so in this case, we can only have SN2 occurring. Next up, when we go to primary, again, the carbocation would be unstable here, so you can't have SN1 or E1. And then there's very little steric bulk here, and so the SN2 is going to be the major pathway. However, if you did want to push an E2 reaction to occur, you could. What you would need to do is use a strong, bulky base. Maybe something like DBU or DBN, for example. And then when we get to this secondary, allylic and benzylic, this is when things get a little bit more complicated. And so we can split them up versus SN1 and E1 or SN2 and E2. If we have SN1 or E1, we'll use a weak nucleophile / base. And that's because strong nucleophiles / bases will prefer to go to the SN2 E2 route. So let's take a look at some examples of these, some of our reagents. So over here, we'll put things that are strong bases and strong nucleophiles. And so these will prefer SN2 and E2 reactions. And so examples of this are something like hydroxide. Maybe something instead of hydroxide, have like a methoxide or ethoxide, right? Very similar, the O- motif. Another example would be this deprotonated alkyne. That is also a strong nucleophile and a strong base. So both of these will prefer SN2 and E2, right? So when you're thinking about secondary substrates, you first look at the substrate and then you start taking a look at the reagent. And then if it's a weak base and a weak nucleophile and or weak nucleophile. This is something like water, a protonated alcohol, a nitrogen that's neutral, right? These kinds of things. They don't have any kind of charge, and so they're very overall pretty weak. And so depending on your reagent, you can choose between SN1 and E1 or SN2 and E2. And then how do you differentiate between the SN1 and E1? And so this is pretty difficult to do. In most cases, you're going to get a mixture of products, right? There's no really great way to have one or the other when it comes to these secondary substrates. However, one thing that we know is that if we heat things to a good bit, it's going to prefer the elimination product, right? Heat prefers elimination, or heat favors elimination. And so what we can say is if we heat it, we're going to go more towards the E1 pathway. And if we don't include heat, then we're going to go more towards the SN1 pathway, right? So for example, under this solvent conditions part, if you wanted to push this towards an E1 reaction, you could write something like heat. But overall, you are going to get a mixture of the two compounds. SN2 and E2 are a bit easier to control. And so one thing we can do is, instead of using something that's both a strong nucleophile and a strong base, we can just use one or the other. So if we want an SN2 reaction to occur, we can use something that's only a strong nucleophile, right? That isn't a strong base. And if we want an E2 reaction to occur, we could use something that is more base-like and less nucleophilic, like a bulky base. So we have a different set of reagents here. We have reagents that are strong nucleophiles. And weak bases. And so this will prefer SN2 pathways. Examples of this are sulfur compounds where we have the negative charge, halides, right, your chlorine, bromine, iodine. Even protonated sulfur compounds are generally pretty strong nucleophiles. And then another good example are cyanides, right, CN-. That's generally a strong nucleophile. It's a moderate base, but for our case, we're just going to say that it's a weak base. And so that'll push you towards SN2. And then the other option is to have strong bases and weak nucleophiles. And so these are generally going to be our bulky bases. And this will push the reaction towards an E2 pathway. So that's something like DBU/DBN. Something like our terp butoxide, although you do have to be careful with terp butoxide. If the substrate is primary, chances are it will undergo an SN2 reaction. And then another one is sodium hydride. This one's not bulky, but it's not nucleophilic, right? So this is essentially just an H-. So this can attack an acidic proton and form H2 gas and then just leave, right? So one way to decide between SN2 and E2 is to take a look at your reagent and decide if it's only a nucleophile or only a base. But what if you have something from this column right here where we both have a strong base and a strong nucleophile? Well, the story is that you're going to get both the SN2 and E2 products. However, you can, under certain conditions, push them to favor one product over the other. And so just as we previously said, heat will generally favor elimination reactions. And so if you heat this reaction to a good bit, you'll follow elimination. Now, what we mean by heat is not just apply any amount of heat. We heat pretty much all reactions to get them to going. But when we say heat, we mean like kind of an excess amount of heat. So you'd have to do a bunch of trials and see what experimentally works. And so if you want to push towards E2, you can heat the reaction. If you want to stay towards SN2, you can add no heat. Or you can also think about what kind of solvents you want to use. If you want to push towards SN2, you generally want to use a polar aprotic solvent. This will make our nucleophiles more nucleophilic and then push it towards the SN2 pathway. And so you can see the secondary is really where it gets a bit tricky. And then finally, we have tertiary alkyl halides. Tertiary alkyl halides cannot undergo SN2 because of the steric hindrance for the backside attack, and so SN2 cannot occur. If you have something that is a strong base, then we will have E2 occurring here. And then if you have something that's a weak base slash nucleophile, we'll have both SN1 and E1 occurring. If we want to push towards the E1, we can heat this, and that'll give us more E1 products. And then for SN1, our nucleophile doesn't actually have to be weak. It can be a strong nucleophile as long as it's not basic, right? So something right here, these would work for these tertiary SN1 reactions as well. It can't be a strong base because if it's also a strong base, the E2 pathway is going to be preferred. And so all of this kind of comes down to practice, practice, practice. Do a bunch of practice problems, use these conditions, think about what's your substrate, what's your reagent, what's the solvent, what's the conditions, what product is that going to lead you to.